Panspermia, from ancient Greek pan, all, and sperma, seed, is the hypothesis that life exists throughout the universe, distributed by space dust, 1 meteoroids, 2 asteroids, comets, 3 and planetoids, 4 as well as by spacecraft carrying unintended contamination by microorganisms, known as directed panspermia. The theory argues that life did not originate on Earth, but instead evolved somewhere else and seeded life as we know it. Panspermia comes in many forms, such as radiopanspermia, lithopanspermia, and directed panspermia. Regardless of its form, the theories generally propose that microbes able to survive in outer space, such as certain types of bacteria or plant spores, can become trapped in debris ejected into space after collisions between planets and small solar system bodies that harbor life. This debris containing the life forms is then transported by meteors between bodies in a solar system, or even across solar systems within a galaxy. In this way, panspermia studies concentrate not on how life began, but on methods that may distribute it within the universe. 10, 11, 12. This point is often used as a criticism of the theory. Panspermia is a fringe theory with little support amongst mainstream scientists. 13. Critics argue that it does not answer the question of the origin of life, but merely places it on another celestial body. It is further criticized because it cannot be tested experimentally. Historically, disputes over the merit of this theory centered on whether life is ubiquitous or emergent throughout the universe. 14. The theory maintains support today, with some work being done to develop mathematical treatments of how life might migrate naturally throughout the universe. 15. 16. Its long history lends itself to extensive speculation and hoaxes that have arisen from meteoritic events. In contrast, pseudopanspermia is the well-supported hypothesis that many of the small organic molecules used for life originated in space and were distributed to planetary surfaces. Panspermia has a long history dating back to the 5th century BCE and the natural philosopher Anaxagoras. Classicists came to agree that Anaxagoras maintained the universe, or cosmos, was full of life, and that life on Earth started from the fall of these extraterrestrial seeds. 18. Panspermia, as it is known today, however, is not identical to this original theory. The name as applied to this theory was only first coined in 1908 by Svante Arrhenius, a Swedish scientist. 14. 19. Prior to this, since around the 1860s, many prominent scientists were becoming interested in the theory. More recent advocates include Sir Fred Hoyle and Chandra Wickramasinghe. In the 1860s, there were 3 scientific developments that began to bring the focus of the scientific community to the problem of the origin of life. 14. Firstly, the Kant-Laplace nebular theory of solar system and planetary formation was gaining favor, and implied that when the Earth first formed, the surface conditions would have been inhospitable to life as we know it. This meant that life could not have evolved parallel with the Earth and must have evolved at a later date without biological precursors. Secondly, Charles Darwin's famous theory of evolution implied some elusive origin because in order for something to evolve, it must start somewhere. In his Origin of Species, Darwin was unable or unwilling to touch on this issue. 22. Third and finally, Louis Pasteur and John Tyndall experimentally disproved the now superseded theory of spontaneous generation, which suggested that life was constantly evolving from non-living matter and did not have a common ancestor, as suggested by Darwin's theory of evolution. Altogether, these 3 developments in science presented the wider scientific community with a seemingly paradoxical situation regarding the origin of life. Life must have evolved from non-biological precursors after the Earth was formed, and yet spontaneous generation as a theory had been experimentally disproved. From here is where the study of the origin of life branched. Those who accepted Pasteur's rejection of spontaneous generation began to develop the theory that under unknown conditions on a primitive Earth, life must have gradually evolved from organic material. This theory became known as abiogenesis and is the currently accepted one. On the other side of this are those scientists of the time who rejected Pasteur's results and instead supported the idea that life on Earth came from existing life. This necessarily requires that life has always existed somewhere on some planet, and that it has a mechanism of transferring between planets. Thus, the modern treatment of panspermia began in earnest.